So I am going to read the question number 36. The ratio of bulk modulus of elasticity for an ideal gas in isothermal condition to adiabatic condition is given by. So if I go for isothermal, in isothermal process, Pb is equal to constant, P is the pressure and V is the volume, K is a constant. So if I differentiate this equation with respect to the volume, so we'll get P dV over dV plus V dP over dV, and differentiation of this constant will be 0, and V dP over dV, that is equal to only P with negative sign will be here, because जब हम लोग इसको सॉल्व करेंगे तो dV over dV is equal to 1, P राइट में जाएगा, निगेटिव होगा, और मैंने उस निगेटिव साइन को यहाँ पे लिखा हुआ है. When pressure will increase then volume will decrease. So minus sign will indicate कि when pressure will increase then volume will decrease, and this is the formula of bulk modulus. So we'll write at constant temperature ET. So ET is equal to P. This is very important relation number 1. And this is called bulk modulus of elasticity for an ideal gas in isothermal condition. And similarly, if I go for adiabatic, in adiabatic, you know, PV power gamma is equal to constant. So when you will differentiate with respect to the volume, we'll get once again the bulk modulus of elasticity for an ideal gas in adiabatic condition, ES is equal to gamma times of P, because P to the power gamma is here, and S represent the entropy, because adiabatic process entropy will remain constant. So this is my relation number 2. And if I go for the ratio ET upon ES, so we'll get P upon gamma P. P is the initial pressure and that will cancel out. You know the value of gamma is Cp upon Cv. So we'll get Cv upon Cp. And this is the ratio of in isothermal condition to adiabatic condition. So on behalf of that, we can say my option number 1 is correct. So let's move on question number 37. So now I am going to read the question number 37. The value of m so that elongation in both the identical massless rods are same is. So if I go for the free body diagram and if I calculate the tension in lower part, lower rod TL, so that is only mg, lower rod. And if I go for tension in upper part, so that is mg, this mg and this mg. We'll add them, so we'll write mg plus mg, right? Because this is the capital M and this is the small m. So this is relation number 2 and this is relation number 1. But question says the value of m so that elongation in both the identical massless rods are same. So if elongation are same, so we'll write the elongation in lower part, that is equal to elongation in upper part. So tension is calculated by, you know, the force T, tension in lower part upon area into Young modulus, and that is equal to tension in upper part. This is lower L and this is upper, divided by area of cross section and Young's modulus of the material. So A by is cancel out, and I know the value of tension in lower part is mg and the tension in upper part is small mg plus capital Mg. So capital Mg will cancel out and we have small m is equal to 0. So we can say the value of mass is 0. So my option number 3 is correct. So let's move on. Question number 38. In the question number 38, a small block M is attached at the bottom end of elastic massless rod, length L, area A, and Young's modulus Y, elastic energy stored in the rod. So if this is the rod and this is the mass M, you know energy stored is given by 1 by 2 into force into elongation delta L. If I divide by area A, initial length L, and AL will be here, I am going to multiply AL, numerator and denominator. So this is my relation number 1, and I know from the formula of Young modulus, stress, longitudinal stress to the longitudinal stress is delta L and initial length, because you know Young's modulus is the ratio between longitudinal stress to the longitudinal strain within limit of elasticity. So if I go for elongation by this relation, elongation is given by force, initial length, area into Young's modulus, and this is my relation number 2. If I use this elongation from equation number 2 in equation number 1, so we'll get energy stored is 1 by 2 into F upon A. A is the area of cross section, and delta L is force into length into AY into 1 upon L into A into L. So F upon A is there, F upon A is there, so we'll write 1 by 2, because F upon A is the stress, so we'll write stress with the whole square, and this length and this length will cancel out, so we have stress square into A into L upon Y. Y is the Young's modulus, and I know the value of stress is force. Force is mg, so we'll write mg with the upon A, because A is the area of cross section, with the square, and 1 by 2 is there, so you have to be very careful, into AL divide by Young's modulus Y. So on solving, when you will solve this, we'll get mg whole of square, initial length upon 2 area and Young modulus, because this area is cancel with this area, because इस area के पास ये whole of square है, तो यहाँ से एक area cancel हो जाएगा. I have mg square L upon 2a by. So this is the final energy stored in the rod. So we can say my option number 2 is correct. So let's move on. Question number 39. For a liquid and glass, if I go for question number 39, for a liquid and glass interface, if adhesive force is greater than cohesive force, then the angle of contact is. So this is a factual question. So you know very well, in this situation angle of contact will be less than 90 degrees. So my option number 3 is correct. And let's move on. Question number 40. So now I am going to take question number 40. A container is filled with liquid up to height h as shown in figure. There are 2 holes in container such that water coming out from them have same range. If the range of water coming out of the holes is half of maximum range, then the distance x between these holes is. So now if I go for diagrams, let's suppose this height from free surface is h1, and for the second hole the position of second hole is h2 from free surface, and from the ground the position of second hole is h. And according to the problem, this is the range, but range is half of maximum range, and we know the maximum range is equal to the height of the liquid, so we'll write h by 2 will be here. And now I am going to take the calculation. So I know the range of this is given by 2 root of h minus h into h. But as per the question, this range is h by 2. So when I will place the value of this range, h by 2, but 2 is there, so we'll write h by 4 is equal to h minus h square. So if I take square on both sides, we'll write h square upon 16. So this is small h capital S minus h square. If I rearrange this equation, so we'll write h square minus h into h plus h square upon 16, that is equal 0. So this equation, just like a quadratic equation, ax square plus bx plus c is equal to 0. So if I compare that, a is equal to 1 and b is equal to minus h and c is equal to h square by 16 and x is equal to small h. If I compare, small x is equal to small h. So now I am going to take Sridharacharya method, and for this purpose I need a board. So now x is equal to minus b plus minus b square minus 4ac upon 2a. This is Sridharacharya method. And now if I place the value of b, so b is equal to minus h. So when I will place the value, we'll get capital H plus minus b square minus 4a is 1 and c is h square upon 16 divided by 2 into 1, because value of a is 1. So I have h by 2 plus minus 16h square minus 4h square. So when you will subtract, we'll get 16 minus 4 means 12h square upon 16 and 1 by 2 is there. So 4 3s are 12, 4 4s are 16. So I have h by 2 plus minus 1 by 2 root 3, but h in terms of square, so this is capital H, and divide by 2. So final value of this is h by 2 plus minus 1 by 4 root 3 into h, and this is the value of small h. But as per the diagram, if I go for h2, because h2 is the position of second hole from the free surface, so we'll write positive sign h by 2 plus root 3 h by 4, and h1 is the position of first hole from the free surface, so we'll take h by 2 minus root 3 h by 4. But I need to calculate h2 minus h1 because I want to calculate the value of separation between these two holes. So h2 minus h1, when you will subtract, h by 2 and h by 2 will cancel out and this minus sign will becomes plus. So root 3h by 4, root 3h by 4 will add them, then you will get root 3h by 2, and this is the value of x, root 3h by 2. So by this calculation we can say that my option number 4 is correct. So let's move on, question number 41.